Okay, I'm going to do a really simple, easy video on how to take measurements with your microscope. If you've used a compound microscope, you'll notice that it typically has 3 lenses on the bottom. There's going to be a 4 lens, a 10 lens, and a 40 lens. And then there's your eyepiece, and the eyepiece actually has a magnification of 10. So the magnification for the 40 lens actually would be 40 times, because it's actually the magnification of the lens times the eyepiece. And the magnification for the 10 lens is actually 100, because it's actually 10 times 10. And the magnification for the 40 lens is actually 400, because it's 40 times 10. So what we're going to do is we're going to figure out how we can use field of view and magnification and your camera on your phone to determine how big something is. So the first thing we need to know is what is my field of view. So in this case, and then it depends on the microscope, so it might be different for if you're looking at a microscope. So don't assume that your field of view is always going to be the same for everyone. But in this case, I'm looking at a ruler. The ruler has millimeter markings. You can see the millimeter markings, 1 millimeter spacings. And this field of view is about 5 millimeters. It's a little more than 5, but I'm going to keep it simple and just say that my field of view, which I'm going to abbreviate as f of v, is roughly 5 millimeters. Okay, I can be a little bit more precise, but that's good enough. Now, to determine my field of view for the other lenses, it's quite easy. I take my field of view for my lowest lens, which is my 4 lens, and I'm going to multiply it by 4, the lowest power lens, over the higher power lens. So in this case, for the 10 times lens, my field of view will be the field of view of the lower lens, which was about 5 millimeters. So it's 5 millimeters times 4 over 10. And for my 40 lens, it's going to be 5 millimeters times 4 over 40. So you can see it's the lower power lens over the higher power lens. Basically, that's the formula. So in this case, the field of view at 10 times will be 2 millimeters, and the field of view for the 40 lens will be exactly 0.5 millimeters. Okay, so that's how you do field of view. And we're going to use that now to figure out how you actually determine the size of an object. So what you can do then is, once you know your field of view, and for our previous examples, if we use the eyepiece, the 4 times eyepiece, remember the actual magnification is 40. That's the actual magnification. For the 10 times eyepiece, that actual magnification is 100. And for the 40 times eyepiece, that magnification is actually 400. But we worked out in our example that the field of view for the 4 lens is 5 millimeters. Okay. For the 10 lens, it was 2 millimeters. And for the 40 lens, it was 0.5 millimeters. I don't know why I wrote 0.55. It's just 0.5. Okay, that's important, because to figure out how big something is, we need to know that field of view diameter. So this is the field of view diameter that has been determined. Okay, and what we're going to do is we're going to figure out, like, say for example, like say here's that millimeter marking, which I'm going to highlight here. Okay, and I want to know how wide is that millimeter marking. So I'm going to figure out its width from here to here. So what I can do is, on my phone, I can measure it. Let's say I measure it with a ruler, and I find that it's 0.5 millimeters wide. Okay, that's the length or width of my specimen. I divide that by the actual width of my pictures, which in this case looks like it's from about there to there. So let's say I measure that, and it works out to about 3.5 millimeters. So the formula is length of your specimen, or width of your specimen, divided by the actual width of your picture, multiplied by my field of view diameter. Now this picture was taken at a magnification of, or using the 10 lens. But remember, that actual magnification is not 10 times, it's actually 100 times because the eyepiece is also 10 times, right? So 10 times 10 is 100. So using the 10 lens, though, we know from the previous example that the field of view was 2 millimeters. So then the specimen's width, the specimen being just a millimeter marking, has a width of basically 0.5 over 3.5, which is exactly 1/7 times 2. And I believe that ends up being, let me just double check really quickly. My calculator ends up being about 0.29 millimeters wide. Okay? So that's one example. I can do another example. Here in case we're looking at an organism. Let's say I wanted to measure the length of this microorganism. And in this case, we're looking at using the 40 lens. And again, that means the magnification is actually 400 because the eyepiece is times 10. Then let's say that this specimen is exactly on my screen 3 centimeters long. So it's 3 centimeters long. And my width from here all the way to here, let's say it's roughly 7.5 centimeters. Okay? So it's the length or width of your specimen, which is this, over the diameter of your field of view of your picture, which is this, times the actual field of view diameter. But assuming that the field of view diameter is the same as assuming that the field of view initially was 5 using the 4 lens, then we can work out that the field of view for the 40 lens is 0.5 millimeters. So we can go ahead and multiply that by 0.5 millimeters. And we get an answer of, so that's 3 divided by 7.5 times 0.5 equals 0.2 millimeters. So this microorganism, well, at least this one, has a length of about 0.2 millimeters. Okay, thanks a lot. Bye-bye.